Hi class, in this video we will analyze a few more function chain examples. I have a function g of t and h of x, and we will compose them to form the Hog function, or h of g of t. Recall that h of g of t means in the h function you input the g function, which means that we actually analyze the g function first and the h function second. Sometimes that's confusing when you learn this notation for the first time, but if you write it like this, well, please excuse my dear Aunt Sally, we do what's inside of the parentheses first. Okay, let's get to it. So we'll start with a g function, and let's compute g of 1. Well, g of 1 is 5, and now what does h do to a 5? Well, it sends it to 6. So that means the Hog function takes 1 and sends it to 6. 2, under the g function, gets sent to -2, and then, well, what does h do to -2? -2 isn't in the domain of h, so that means 2 is not going to be in the domain of our Hog function. And we keep playing this game. 3 is mapped to 3, and the h function maps 3 to 4, so 3 is mapped to 4. 4 is mapped to 5, and 5 is mapped to 6, so 4 is mapped to 6. 5 is mapped to 0, and there is no 0 in the domain of the h function, so we exclude 5 from the Hog function. 6 to -3, again, there is no -3, so we exclude 6. 7 to 3, and the h function sends 3 to 4, so 7 gets mapped to 4. Okay, now we have the h composed with g function. Let's go ahead and make a mapping diagram of this function. In the domain we have 1, 3, 4, and 7, while the range only contains 4 and 6. So the arrows will go from, let's see, 1 to 6. 3 is going to hop over this and get mapped to 4. 4 gets mapped to 6. And 7 is going to make a double hop to 4 as well. Okay, now let's analyze the go function. So the go function, or g composed with h, this time we will start with the h function and then chain the g function onto it. So in the domain of the h function, -1 is mapped to 3, and 3 is also mapped to 3 with the g function, so -1 is mapped to 3. 3 gets mapped to 4, and 4 gets mapped to 5, so 3 is mapped to 5. 4 is mapped to 4, and 4 is mapped to 5, so 4 is mapped to 5. 5 is mapped to 6, 6 to -3, so 5 is mapped to -3. And finally 7 is mapped to pi, and pi is not in the domain of the g function, therefore 7 is not in the domain of our g composed with h function. Let's create a mapping diagram. So in the domain of this function we have -1, 3, 4, and 5, and in the range we have 3, 5, and -3. So the function maps -1 to 3, 3 to 5, 4 to 5, and 5 to -3. I hope this helps you understand the basic idea of function chains. Let's do a significantly more challenging example. So we're going to start with functions f of x is the square root of x plus 2, and functions g of x is 1 over x. The first thing that we're going to do is the easy part. We will compute f after g evaluated at an x. Well, that's just f with the input of g of x, but that's f of 1 over x. And what does f do to something? It takes the square root of that something and adds 2. Hence, it's the root of 1 over x plus 2. Okay, now for the challenging part, we need to compute the domain and the range of this function f composed with g. Here's how we'll do that. The first thing that we need to do is understand the problem. remember that in order to create a function chain, the range of one function has to be exactly the domain of the other function. And if we just write down a couple of functions, it's very unlikely that that actually happens. Most likely the picture will look like this. That is, it could be the case that we have some x in the domain of G, and G sends it over here into, let's say, Y, but now, well, Y is not in the domain of F. So what we need to do is somehow guarantee that the x's that we choose in the domain of G end up inside of this overlap space. This is the intersection of the range of G and the domain of F. What we want to do, so here's what we're going to do. Step 1 will calculate the domain of G and the range of G, domain of F, and the range of F. Step 2, we need to figure out what is this overlap space. This is step 2. Step 3 is we're going to find the restricted domain of G. What that means is we're going to find some subset over here so that this space gets mapped exactly to the overlap. This is step 3. Once we have that, then we can say, all right, well, what does F do only to the overlap? Well, F is going to send that overlap to some subset of the range, and that's our final step. You see, step 2 we just need in order to find step 3 and step 4. Once we have step 3, this is the domain of the composition. In our case, we're applying F after we apply G, so that's F composed with G. And similarly, step 4, well, that is the range of the composition. So one more time. Write down the domain of G, the range of G, domain of F, the range of F. Find out where the range of G and the domain of F are the same. Find the overlap. Once you have the overlap, then we find the subset of the domain of G that maps to that overlap. Finally, we'll see what does F do only to the overlap, and that will be our range of the composition. So, I know that sounds complicated. Let's do an example. So our step 1, we write the domain and ranges of each function in the correct order. The correct order is important. You'll see why here. So we're computing F composed with G, which means we apply G to X first. So that means I'm first going to determine the domain and range of G. Now I'm going to do this kind of fast. On a test, I'll probably let you use Desmo so you can figure out these domains and ranges faster. However, I still want to see the work that I am doing, step 1, step 2, etc. So this is the reciprocal function, and I think we did this one in class. It takes real numbers except for 0 and returns real numbers except for 0. Okay, now we will compute the domain and range for the F function, and here's what I like to do. I'm going to write it here. So the domain is going to be, well, this is the square root function of x plus 2, so I think it's going to be -2 all the way up to infinity, because we don't want to put any negatives underneath that square root. So I scooted f over so that the range of g is sitting on top of the domain of f. Finally, let's compute the range of f. Well, it's a square root function, and this +2 business is moving the square root function left and right. It's not moving it up or down. That tells me the range is going to be from 0 to infinity. Okay, we are done with step 1. Now we can move to step 2. Step 2 is determine the overlap. What that means is find the intersection of these two sets. Oh, well, that's not so bad. We can even write down that overlap in one line. It's the real numbers, take away 0, intersected with -2 to infinity. Remember that intersection means and. So we are looking for numbers that are real but not 0 and between -2 and infinity. Well, think about that a little bit. What that's going to be is this set, -2 to infinity, but we still need to take away 0 because 0 lives in here, and this says we're not talking about 0, so we need to take away 0. Okay, we've just found the overlap. Now we can find the restricted domain. When you're finding the restricted domain, it's important to realize that this is the domain that we are restricting, the r take away 0. So we need to look at the g function. And in particular, we need to guarantee that the output of our g function, that needs to live in the overlap. That means, well, what is our output? Our output is the number of the form 1 over x. So what that means is 1 over x needs to live in the output. That means it needs to live inside of this space. It needs to be, between -2 and infinity and not 0. Well, we can just write an inequality for that. It needs to be in between -2 and infinity, but it can't be 0. Well, obviously, it can't be 0 because it's already 1 over x. So really, this is the only piece that we need to think about. Let's talk about this portion of the piece. First, that's kind of a silly portion because all real numbers are less than infinity. So this piece isn't really telling us anything. This one is the important piece. Let's solve that. -2 is less than or equal to 1 over x. That implies that, well, let's reciprocate. -1 over 2 is the reciprocal of -2, and the reciprocal of 1 over x is x. And if I reciprocate an inequality, I have to reverse the inequality as well. Okay, well, we've almost found the restricted domain. If you're going to make a mistake on this, well, it might be on this part, because this is really the challenging part to think about. Thus far, we have determined that the restricted domain has to be a number less than or equal to -1/2. But if we really think about this inequality, we can see other things as well. In particular, we can see that if x is any positive number, it satisfies this inequality. Let x be 1. Is 1 less than or equal to -1/2? Well, no. But clearly, if x is 1, 1 over 1 is greater than or equal to -2. That checks out. In particular, if x is any positive number, then 1 over a positive number is greater than or equal to -2. So this is not the full story. We need to add on to it, or x should be greater than 0. Now we have our restricted domain. Again, that would be, I think, the hardest part for us to find as students. Finally, let's find our restricted range. The restricted range is going to be for the f function in this particular case because we're applying the f function after the g function. This is typically a little bit easier to figure out. You just need to look at what we are feeding the f function. And remember, what we're feeding the f function is the overlap. So when x is -2, the square root of -2 plus 2 is going to be, well, 0. And then as x becomes arbitrarily large, well, the square root of something really, really large is still really, really large. So this is almost the restricted range. The problem is that, typically the square root function, we can put 0 into it, the square root of 0 plus 2. But in our overlap, we've said we can't use 0. And if I can't use 0, then that means the number f of 0 is no longer in the range of my function. What I'm saying is we need to take away the number f of 0. Again, we're not letting the input of this function be 0, so we have to take that out of the range, that being f of 0. And well, what is that? Well, that's from 0 to infinity. Take away, well, f of 0 is the square root of 0 plus 2. That's the square root of 2. Okay, now we have our function formula, f composed with g evaluated at x is the square root of 1 over x plus 2. And we know that this function goes from our restricted domain. I'm going to write this in a nice pretty way. It looks like it's from -infinity up to -1/2, including, or means union, not including 0 up to positive infinity. This is the domain of our function. And the range, well, that's this set. And I'll write it in a pretty way like this as well. I guess that's from 0 up to the square root of 2, but we're not including the square root of 2. And we're going to union that with, well, the square root of 2 all the way up to infinity. Okay, class, I know that that was a long and challenging problem. Make sure to think of some questions to ask in class, or you can put your comments and questions in the YouTube comment section. Thanks, class. Have a good day.